Okay, so we're here to talk about server-sent events. I really appreciate you all. It's great to see such a good crowd here. I'm gonna, let's see, why is my not clicking now? Come on. Okay, there we go. It worked. Okay, so I'll go through quick, just for those of you who don't know me already, I'm a developer experience engineer at LaunchDarkly. Been there for about 2 years. It's a great company. If you all are interested, come by the booth, learn more. I'm also, I've written some books. I'm a co-author of the Jamstack book with my friend here, Ray. And I do a lot of, I do some newsletters, and I do a lot of community stuff. Some of the stuff I really like to talk about is I do run a community called cfe.dev. I have a bunch of events coming up all the time on there. They're all virtual, and they're all free. I've got one coming up on Halloween called Haunted DevOps. If you're a DevOps person and you want to join, we have 5 speakers all afternoon, some great speakers on DevOps. And if you happen to be in the Orlando area, which is where I'm from, I run the Orlando Devs organization there, which is the biggest developer organization in Orlando. Anyway, so that's it about me. Again, I work at LaunchDarkly. If you don't know about LaunchDarkly, we're basically a feature management service that you can come by the booth and learn more, but basically it allows you to release your features, without having to just push everything at once. It could be in the code in production, and yet the feature is not running, basically. So if you've all used feature flags, that's effectively what it is, but you can get much, much more advanced than your kind of typical config feature flags. And if you want to learn more, or you want to get that Keychron keyboard that we're giving away, you can sign up for our conference. It's a virtual conference coming up on the 25th and 26th, where we're going to be releasing a lot of new features. Anyway, that is it for my pitch portion. Traditional server-side model of server responses, where a request is made, the server does its thinking and stuff, and then it sends back a response, right? We've all done this stuff. So it works fine, but okay, when you're doing long-running processes and things like that, it can be really slow. And we generally have solved this problem with spinners, right? So server's thinking, let me show you a spinner for a long time, and that's really not always the greatest user experience. So I was taking ChatGPT. If you've used ChatGPT, this takes a long time for it to get the response. Now, if you were to just wait for the server to actually respond, this is what it would look like. You would click, and you'd wait, and wait. It actually takes a long time, I'm not gonna. Anyway, this would not be a great user experience, right? Your user ends up thinking okay, maybe this isn't working. Maybe you're waiting on your computer to update, I don't know. That's what it feels like, right? When I was, but all right, finally got a response. That's how long it would take. So that's not how ChatGPT works in reality, though. As you know, I'm sure you've all used it. It starts spitting out a response like that, right? So basically, as the server is generating the response, it's sending back the data, and it starts spitting it out. And it's not just some simulated typing thing. They're actually using server-sent events, which we'll talk about. Obviously, that's the whole point of this session. But the process takes the same amount of time, right? Ultimately. This is a much better user experience for the user than watching and waiting for the server to process the result. Other things you might want to do, that it's not just about the server load times. Obviously, sometimes we need to notify the user that something's changed. I'm thinking a stock ticker, right? You want to be able to push changes that are coming from the stock ticker. Or another kind of canonical example is a news feed or a social media feed. Those are constantly updating. All that information is coming back from the server. Doesn't necessarily require heavy interaction from the client to tell it. It's just we need to update the response constantly. So in the case of LaunchDarkly, we actually use this for all the feature flag. This is how feature flags get updated on the client. So I'm going to show you an example. Obviously, this is me having a lot of fun here with feature flags, but the whole point is you can see how quickly these things happen. So when I click that, and then we start, you can see that immediately the client responds, because what's going on behind the scenes is that basically every time I hit that, it's sending an update from the server via server-sent event over to the client. So this works in all of our SDKs. So you can DJ with feature flags. That was my whole point here. You like that? This is what I spend my time building. So anyway, again, what enables all of these things is server-sent events. So all of like the SDKs with LaunchDarkly, the ChatGPT example, and a number of other things that we'll talk about. They all use server-sent events to manage that. So the basics are pretty simple. I mean, server-sent events, like client establishes the connection, and then once the connection is established, then you can just stream back events. But this is a one-way stream, right? This is only going back, so back to from the server back to the client, right? And that stream continues until it's either closed or disconnected. And actually, we'll talk about the disconnections in a little bit, because that's one of the benefits of this, of using server-sent events. So they're not new. You might not have heard of them. Honestly, I'll be honest, I hadn't heard of them until I started digging into stuff for this, because I kind of knew what was going on in the SDKs, but I started researching about all of this, and I hadn't really realized server-sent events have been around a long time. It's just they kind of got, first of all, they were proposed in 2004, and they were actually first implemented in 2006 in Opera, but they didn't become official till 2011. Still a long time ago, but there was no Edge support until 2020, which kind of limited its usage. And then, and also it kind of got overshadowed a little bit by WebSockets, because you can achieve similar things with WebSockets, but we'll talk about some of the benefits of why you might choose server-sent events instead. So currently, though, it's supported in 97% of browsers globally, so it's pretty, you can pretty much use it anywhere. So recently, server-sent events have gotten a lot more popular, mostly because of interfaces like ChatGPT, but also I'll show you there's a number of APIs that have implemented server-sent events in their API so that they can stream you back data. So including ChatGPT's API actually will send you back, if you call their API, they'll send it back via server-sent events. And it's the key to consuming server-sent events is this event source. So the event source interface connects the event stream and listens. In this case, I'm listening to any event that gets sent back. One of the things I want to point out here is if you can see that event source, maybe the color's a little hard to read, I apologize, but all I'm passing is an API endpoint here, right? Like I don't have to specify any kind of additional things. In fact, there's nothing else to specify. That's all it takes is a URL, kind of like, a fetch. And then I can listen for messages that are sent back from that. So in this case, the messages send me back a type and a data, and I can work with either one of those things. And another example would be to take that add an event listener for a specific type of message. So this data will come back with a type, and I can say listen only for this type, and that way I can write different code that responds differently. So a kind of common example you see done would be you have if have a news feed or something like that, I might have something that was added and something that was updated or something that was deleted. So I can actually write different code to respond differently based on the type of message that I'm sending, whether it's an add, update, or a delete. So on the server side, you specify with the types. It's not like some predetermined set of types, so you can create whatever types you need for your application to listen from. So WebSockets and server-sent events can accomplish the same things from a read standpoint. Why choose server-sent events over WebSockets? Well, first of all, as you saw, that's a simple API. That is all. I just specify the URL of the endpoint, and that's it. That's the whole thing. It's also a little more secure because I'm not opening up a channel to send writes. I'm only opening up a channel to read, so it's a read-only kind of data. And then the other thing is it's actually much easier to create on the server because it's only HTTP. I don't need to do TCP. So basically, I just send back a readable stream, and that's it. It's a regular GET request to an HTTP endpoint. It's much easier to code on both ends. Another thing is that unlike WebSockets, it does actually have an automatic reconnection. If for whatever reason that stream gets disconnected, it will actually keep trying to reconnect at intervals to reestablish that connection, which will help in the case, like for instance, in the case of feature flags. We want to make sure that that connection continues, right? We need to make sure that the stream keeps coming. So, as I indicated earlier, all of our SDKs do actually use it. This is hard to read. I apologize that. I didn't realize the screen would be small. But so basically, what our SDKs do is it initialize, to kind of give you a little bit how we use them. When you initialize the LaunchDarkly client, it actually pulls down flag data. Like if you're in the browser, it's going to pull it down and stores it in local storage. It pulls down flag values for that particular user. If you're on a server, it's actually going to pull all the rules it needs to be able to evaluate. But anyway, point being, it pulls that down and then it opens up the server-sent event stream, the event source stream. That is pulling updates. So essentially, anytime you change something in LaunchDarkly, we send an event over, and that updates the local storage cache that then you can respond to in your application. So point being, like we use them extensively, and actually, if you couldn't see that code very well, but if you could, you're paying close attention. We actually have like a polyfill here that our SDK uses. So obviously, even though it's supported by 96-point-something% of browsers, we actually want this to be fully supported. So we actually have a polyfill that is open source as well, but it's a fork of a different polyfill, but that we released as open source as well. But it also, this is the polyfill. The thing that I highlighted here that, again, it's hard to read, is that this polyfill is primarily actually for Node. And you may be thinking like, okay, so far we've only really been talking about browsers, right? This is a browser API, but you can do server-sent events on the server. And I don't mean like sending server-sent events. I mean server-to-server server-sent events, right? So you can use that implementation that we have there for Node.js. There's a bunch of other implementations we'll talk about in a moment. But so let's say you need to send updates from one server to another. Server-sent events can be a way to do that, but you have to have obviously somebody has to implement the browser API in whatever language you have. So LaunchDarkly uses this actually for all of our server-side SDKs, have streaming updates to those flag rules. So on the server, I kind of mentioned it earlier, but on the server what happens is we pull down all the flag rules initially, store them in an in-memory cache, and then we use this server-sent events to do server-to-server updates, streaming updates of those flags. So that way, anytime a flag changes, your server is notified as well. So the point is, functions just like the server to client communication, except in this case, we're doing server to server. It's actually really useful. And we have, in fact, a bunch of open source libraries. So we have implementations for .NET, Ruby, Python, Java, Swift, and Rust. They're all open source. So if you want to do server-sent events on the server, you can use one of these libraries to actually implement that on the server as well. So that's actually the slide portion. I do have examples that I want to walk through. So I think, because that's more fun. I think, the basics of server-sent events is not really that complicated. Although I will say that it wasn't exactly, I had some struggles, which I'll talk through those, and so you can kind of know where the pitfalls might be for you. So I have to switch here. Hold on a second. How do I get out of this? I need to get out of mirroring. Stop mirroring. How do I stop mirroring? Here we go. There we go. I want mirror. Sorry about that. It may do that flashy thingy again. There we go. It's thinking. All right. All right. We got it. All right, I know it's about as big as I can get this code without making it like unusable here. Can you all see the code at all, or not really? Yeah? Yeah, you can see it? Okay. All right, so I've got this project set up. There's two aspects to it. One is the front end here, which I've actually built in Astro. I love Astro. Astro is really cool. And so I was like, I'm just going to do this all in Astro. I will tell you, one of the pitfalls is implementing server-sent events in an Astro API function was not easy. I couldn't get it to go. There is an example out there that is actually quite good that sends server-sent events in an Astro API, but it's a very specific implementation that I couldn't get to work with any of the other APIs. So anyway, long story short, Astro's awesome, but you know, you may need to fiddle with it to get server-sent events working inside of their API functions, the way that they package that up and everything. So instead, I have a server here, which is actually just an Express server. So obviously, if you're doing the streaming here, you have to have the server that sends the stream. So this is just a basic Express server. I've got cores set up so I can call it from my other application. I'm going to show you a few examples here. I can actually move this down so I can show more. In this first example, which, let me get it up on the screen too. It should be here. Nope, this is not it. That's the wrong thing, Brian. All right, this should be up. Sorry, I had to reboot my computer, so now everything is not actually running. Okay, so we need to start the server. Okay, starting the server. And I'm going to start the Astro. All right, so that should bring up my application now. Sorry about that. All right, so I've got three examples, a ChatGPT example, a newsfeed example, and a Mastodon API example. So I'll actually show you the ChatGPT. So it's basically the same as your typical ChatGPT response. So basically, I can put whatever prompt I want in here, and then when I click it, I should get the streaming results back from the ChatGPT API. So it's effectively the same UI that you got in the ChatGPT interface. So the way you do that with ChatGPT is, again, one thing to point out, this is just a GET request. Again, there's nothing too complicated here. I actually can get the query and everything and pass it back. So I am just putting a GET request on this GPT endpoint. I am using something. Okay, another thing that I had trouble with was getting the streaming response correct. And anybody who's dealt with streaming, I think, can often be difficult to get the stream response exactly right. So I struggled with that a little bit. And there is a great project out there, which is actually called, it's called Better SSE, which is built specifically for server-sent events. It's just if you're doing this in NPM, this worked great for me. So I'm actually using Better SSE to create the session based on the request and the response. And then I assign that, the session to this result variable here, and then I'm going to call the API and create the stream. So the API has a response type like that you can tell it you want to stream instead of waiting for the response. And then what I'm doing is every time a part of the response comes back, I'm just in that SSE portion of the response, I'm pushing the chunk that it sent me back. So that's all this is. This is just a text string that represents that particular chunk of data that gets sent back. I am giving it, this is just an event type. So all this is like it's saying if, send back that chunk or send back nothing, an empty string. And I'm giving it a type of GPT. Again, this is just arbitrary, the type, whatever I want. But that way, when I'm in the front-end code, I can listen for that. So if I go to my front-end code for, don't need to see my Tailwind config or my layout. Let's open up the front end here. So source, pages. This is the GPT. Again, pretty straightforward. I'm actually opening the stream once you click the little button. That's why the prevent default is there. I am just getting opening the event source to that particular API endpoint. Again, it's just a string. I'm passing a query variable so I can pass the whatever request you're sending. But you could do this via post as well. It doesn't have to be just a simple like URL variable. But then I just add an event listener for that GPT event. And then again, it sends me the type and data, but I don't actually need the type here. I'm just going ahead and replacing out some chunks, because the way GPT sends this back, each of those chunks, they're sometimes part of a word, sometimes a full set of words, and every time it sends it back, it's actually wrapped in quotes for some reason, so you have to kind of strip out the pieces of the quotes. That's all I'm doing there. And I'm adding in line breaks so that it renders properly. So it sends it back with just the character breaks. So I'm just replacing those out. So that's all that's doing there, and then spitting that out. It's really, again, the whole point here is this is super easy to work with. From a front end standpoint, the trickier part I had was just making sure that each of these streams sent back things in the right proper format. So as another example, let's go back. So this one is imperfect because the dev newsfeed doesn't update that often. But basically what I wanted to do was say, like, okay, instead of just running something that like streams back from the API, in this case, what if I'm checking like something like if I was updating a news feed, or I had like a social media feed or whatever, or I wanted to be able to like put a banner up, like said, oh, we posted a new post, and with like something more of that kind of use case. So in this case, what I did was I set up a stream, and it's actually just, because dev doesn't, I had to find a public API. It's just you can see it updating every time it turns green here. It's checking again. So it checks, in this case, every 20 seconds, which for this API is probably too much, but just so that you can see it going on. And this one, all I did was basically similar type of thing. I'm actually checking the API initially to get back the initial response and sending that back. And then I'm just doing a set interval to like check it. It's essentially a polling on the background, but instead of polling it on the client, in this case, I open up that stream and I'm constantly sending updates via that. So that way it's always open. This in a case of like stock ticker or something like that, this might be more constant, but so it's very similar. I'm using that better SSE to create the same response type. I'm pushing, in this case, the whole JSON for the article back with each one. So every time that I check, I'm checking to see like is this new? If it's not new, if it's new, I send it. If not, I send back a null response basically. That way I can, on the client, again, it's very similar to the other one. In this case, I'm actually getting, creating that, I am connecting to my event source, and I'm getting the response and then plugging that response back into a template here so that it outputs that way. And then in this case, if the data is null, I just skip it. So again, it's very simple to set this up, and that way I could just set up a stream that sends me back responses for like if you want to say check if any news had changed or anything you want to send to the client, really. This would be like how to send it with a static API. And then the last one I wanted to show was just Mastodon, which also the Mastodon has support for server-sent events. There are a lot of APIs. When I started digging into it, there are a lot of APIs that actually have started adding server-sent event support right in. So that way you can just kind of call the API and it's going to send you a bunch of events. The one tricky thing here was that, and this is the front end, so I'm going to go back to the back end here. The one tricky thing here that was just that this API, the way it streamed stuff back, was slightly different than the way the ChatGPT streams stuff back. So I had to kind of write it a little bit differently. Other than that, it's mostly like I'm using a library called Masso to to actually read the API client here. So I just give it the streaming URL. I need an access token in this case. I am still using the better SSE to send it back, and then I am basically awaiting the subscribe event, and then I'm switching based on whether it's an update. They do actually, in this case, they will send you back types of like an update, a delete. So that way, if you were really maintaining a Mastodon type feed off of this, you would want to know, like, was this post removed? Was this post updated? So I can actually then update the feed without having to refresh the whole thing. So it does send you back that type. In my case, I am only listening for new posts. So that's why I'm looking for, like, this update is actually going to have new posts. It's not going to have the delete. So that one, okay, I'm going to put this up because just so you how it does work, it actually comes blazing fast at you. So just be prepared, and also be prepared. I don't control what's on this feed, so okay, I'm gonna click it, y'all. All right, it takes, for whatever reason, that API takes about like 15, a few seconds to kick in, and then it starts streaming, and then sometimes it's like, it's super fast. So anyway, you can see like it's constantly updating, but the point being, all of these were relatively easy to implement. You can, and that's really the benefit of server-side events over, like, from a server-side perspective, it was easy to implement. There were some stumbling blocks again. That better SSE library, I highly recommend it if you're using Node. Just because it's a matter of formatting your stream responses correctly, but from the client side, it was super simple. I mean, it's just a matter of subscribing to an endpoint, and then just waiting for the events and responding to them. So that's really the key benefit here. I know I'm running a little short. I know it was a longer presentation. We don't have a lot left, but I'm going to switch to back to my slides here. Sorry. Let's see if this works. All right. We're going to flicker, and we're going to wait. Okay. And now I'm going to get my mouse over there and see if I can actually click this slide. Okay. So those were my examples. I actually have, what I did was I put all those examples up as well at that URL. It's on a GitHub project. You can just scan that. The other thing I put in there is all of these slides, if you're interested, as well as my speaker notes for all the slides, so that helps to add some context, because a lot of them are just images. Lastly, what's in there is all the research that I did for this presentation. So there's a PDF in there where I collected all my research, basically a ton of resources and articles in there that were really good. There's a great resource from Shopify that actually goes through how they implemented stuff. And so there's a lot of great links in there as well. So hopefully that's useful to you. Again, it's the thing I find exciting about this is you can do some really cool things without, and it's actually very simple, whereas like WebSockets very complicated. So there's a lot you can do. Hopefully you can, you go ahead and you implement this. If you need any help, you can always reach out to me, Rinaldi at LaunchDarkly.com. I'm also on Mastodon. I'm not on the bad place anymore. But, yeah, well, you will find me there. You just won't find me saying anything ever. So, but anyway, so yeah, I'm hopefully that project will help you, and I am happy to answer any questions if anybody has any. Okay. Well, you can find me at the LaunchDarkly booth if you happen to have a question that comes up later, and I will be there to answer your questions. Hopefully this helped, and I appreciate you coming.